Okay, we're going to start a topic here in this video that it's kind of obscure for this exam, but it's on a couple of your practice exams, so we really have to talk about it. It's an intermediate algebra topic called factoring polynomials and simplifying rational expressions. It's hard to cover, in a few minutes. This is the kind of thing you spend the whole night on in an algebra class or 2 nights on. And I'm going to cram it into 20 minutes here. So again, it's kind of obscure, but there are a couple problems, or could be, on your exam. Some of the practice exams have them, some don't. And it's kind of really a special problem, special case that was on one of the exams anyway. So, I'd be remiss not to cover it, but it's like a whole little big topic here that I'm going to try to cram in. So what am I even talking about? Factoring polynomials. Polynomials have these terms. We know the distributive property, right? If I just generically put it, some A times B plus C, we distribute the A across. Okay, let me get rid of this marker right away. All right, we're good with that. Well, what factoring is the opposite. It's saying, okay, what common things do I have in these terms that I can extract? So in factoring, I want to extract that A back out of there. I want to start here and I want to create this. Okay, I want to remove something common from the terms. Now what I just did there is I factored out what's called the greatest common factor. And it's just that. We're going to look at what's common between the terms, and we're going to take out what we can. Okay, we're really dividing it out. Okay, we're going to extract it away. So that's the simplest form of factoring. Okay, is we're going to factor out what we call a greatest common factor. If I gave you this problem here, 5x squared plus 30. Okay, now you look at the coefficients and you look at the variables. Well, there is no variable on the 30, so this one we're just looking at a coefficient here. I've got a 5, and then I've got this number 30. I say, what's common between a 5 and a 30? And you can see how that 5 would yank out of there, right? So I'm going to take the 5 out, and now I have to figure out what's left. Well, there would just be a 1 here, or just an x squared, and there would be plus 6. Because if I redistributed it, I would get 5x squared plus 30. Okay, so think of this as the process of undistributing. Okay, we distribute, we undistribute. What about this one? 18x cubed plus 27x squared. Okay, what can I undistribute here? Well, I'm going to look at the 18 and the 27, and there's a process to find the greatest common factor, and it involves factoring down to primes and all that stuff, but I just like to try to think of it. Think of a common factor. Now, if you said 3, I can take a 3 out of the 18 and a 3 out of the 27. If we said that, okay, and I'm going to ignore the variables here for a second. If I take a 3 out of that 18, I'm left with 6x cubed plus 9x squared, right? Well, 3 wasn't the largest common factor because I've still got a 3 inside that 6 and a 3 inside that 9. So I really should have taken out the 9. So you want to identify the greatest common factor. In this case, the coefficient part would be a 9. And then the variable part, you want to take the variable with the smallest exponent. That's actually the greatest common factor. And I know that sounds like a contradiction, but we're talking about common pieces. This one could give me an x cubed, but this one can't. This one can only give me an x squared. So I can only take out an x squared. So if I factor out a 9x squared, what would be left? 2x plus 3. If I redistribute, then you can always check. You can always check. How do I check? I redistribute 18x cubed plus 27x squared. Is that what I started with? Yeah, it is. Okay. So I've undistributed, factoring out a greatest common factor. Okay. All good with that? What if my greatest common factor isn't as obvious to see? In other words, what if I gave you something like this? you know, x squared times a. I'll make this one kind of blatant. Plus 3 times a. I said, hey, what's common? Factor out what's common. And you say, well, a is common. So, okay. Out comes the old a there, and I'm left with an x squared plus 3. All right, fair enough. Well, what if the a didn't look like an a? What if the a was, you know, something in it? Well, first of all, what if I put the a in parentheses? Does that change anything? It doesn't, right? It's x squared times a. Whether or not that a is in parentheses doesn't matter. The a still comes out. I could either leave it in parentheses or not. Okay. That didn't change anything. Well, what if it's not an a? What if it's something else? What if it is an a plus 4 in parentheses? Okay, our temptation might be, well, I got to distribute the x squared here, distribute the 3 here, and then try to find some kind of factor. Well, no, I've got a factor. A plus 4 is common to both of those, right? So that whole a plus 4 is going to be factored out. And then you ask yourself, what's left? Well, you just have x squared plus 3. Okay? So a common factor doesn't have to be a little single, you know, monomial. A common factor could be a polynomial, as long as it's the same, as long as it's common to both pieces. Right? So we always want to spot those, okay? And if once we have them, we want to factor them out. If I tried to multiply this, it's going the wrong direction. We don't want to do that. Okay? So that's that. Now, what if we have something like this? So those are greatest common factors. You look at each term, you know, these things are called terms, and you say what's common, and you undistribute or you divide away what's common, show it out front, and then you figure out what's left over. Let's just do one more. I don't think I said that as great as I could have. What if we had this? X squared times x plus 3 plus 5 times x plus 3. Okay, if I went the wrong way, if I said, well, you got to distribute this, okay, you get an x cubed plus a 3x squared, and then you distribute here, plus the 5x, plus a 15. Well, now look what you have. Now you've got 4 terms. Nothing is common, right? Look at your coefficients. That's a 1, a 3, a 5, and a 15. Nothing is common between all 4 of those. And you've got an x cubed, an x squared, an x, and a 15. Nothing is common. Nothing. Okay, doesn't mean it can't be factored. It means there's nothing in common. We wouldn't want to do that. That's going the wrong direction. Okay, I'm just going to cross it out. Here we've got a common x plus 3. Factor it out. Out the x plus 3 comes what's left? X squared plus 5. All right, so that's how we're going to do these. And if we have one like the one I just crossed out, we're going to have to cross that bridge, okay? And that's our next bridge to cross. What do we do when we have something like that? What happens when I have, you know, an x cubed plus 5x squared plus 2x plus 10? I'm looking for common factors. I have these coefficients of 1, 5, 2, and 10. Nothing is common. I have these variables of x cubed, x squared, x, and then no x. Nothing is common. Well, when that happens and we have 4 terms, we try what we call the grouping technique. Okay, we group the first 2 together, we group the second 2 together, and we look at just the groups and say, okay, group, what's common just between you guys? Well, I have no number in common because I have a 1 and a 5, but my variables, I've got an x cubed and an x squared, so x squared is common. I'll factor that out. I'll be left with an x plus 5. What's common over here? Well, between a 2x and a 10, just a 2 would be common. So I'll say plus 2, x plus 5, right? So I factored out of my first group, I factored out of my second group, and shazam, I now have a common x plus 5. Okay, now these are very strategically set up problems to work like that. Okay, so we get a match here. We got a match. Factor out the match. X plus 5 comes out, leaving me with an x squared plus 2. Okay, so the grouping technique is going to be like that. Okay, it's going to be group them, look at the individual groups and see if you have anything in common, and then see if you have a match after you do that. Okay, now sometimes you might have to shuffle order a little bit, and even if the order is shuffled, you say, well, wouldn't I'm going to rewrite the same problem, except I'll interchange these two pieces. I'll put the plus 2x plus the 5x squared plus 10, and you say, well, what if it didn't? Who says it works like that? Will it work like this? The order is a little bit different. Well, let's see. I don't know. Let's find out. If I factor here, what do I have in common? I have an x, and that leaves me with an x squared plus 2. Over here, what's in common? A 5, and that leaves me with an x squared plus 2. Well, what's common now? X squared plus 2, leaving me with an x plus 5. And if you compare this and that, they are indeed the same, are they not? Factor means things multiplied together. This times that is the same as this times that. The order is not important when we multiply, right? It's the same things, it's just opposite order, so that's okay. All right, all good there? All right. I'm not going to factor trinomials because I didn't see any on your exam, but that's so common, so common. But I don't even want to go down that road. Again, we could spend hours on this factoring and using factoring. Okay, so it's very typical, very classic to have what we call factoring these trinomials. And maybe you remember doing it by this method called AC. I'm not even going to talk about it. Maybe you remember doing it at some point in your life. But again, on the exam, I don't see any trinomials. But what I do see is a special case. Okay, in that case, it's called the difference of two squares. The difference of two squares. Well, difference means subtraction, and square means exponent of 2. So a subtraction of two things that both have an exponent of 2 on them. Okay, so in other words, some a squared minus some b squared. Okay, this factors immediately, and this is just one of these things you have to know. It factors immediately into a plus b times a minus b. Okay, we just have to know that, and this is like a special case, but it's a case that shows up on your exam. Okay, so I would kind of commit that to memory. A squared minus b squared factors into a plus b times a minus b. Well, let's do an example. X squared minus 4. Now you say, well, that's not something squared minus something squared, but it really is, right? Because 4 can be represented as 2 squared. Okay, so there's my a and my b. It's just going to be x plus 2 times x minus 2. Okay. And if we check, if we FOIL this thing out, this is now a FOIL problem, right? X times x is x squared. X times negative 2 is negative 2x. 2 times x is positive 2x. 2 times negative 2 is negative 4. Well, look what happens to those two terms in the middle. They disappear. And we have x squared minus 4. Okay, so it does work. Right? But it's important that you be able to do this, okay? Because it does show up. Now, it won't always be obvious that that's what you have, something squared minus something squared. Like, look at this one, 81x squared minus 49. You know, the first thing with factoring, and I should have done it up there too, I should have said it, you always look for that common factor, right? I would inspect here the 81 and the 49 and say, can I extract something out of there? Can I factor something away? And I can't. Okay, but that's always my first step, is to look at that. Then I look for patterns. Okay, if it's four terms like the one we did a minute ago, I try the grouping technique. If it's 3 terms, we haven't talked about that, but I would try my trinomial methods. That's 3 terms, but again, you're not going to see those. But if it's this, I would try to say, is this a difference of 2 squares? Can I force it into something squared minus something squared? Well, 9x. Everybody squared is 81x squared, right? And then 7 everybody squared is 49. So boom, there's my pattern. Something squared minus something squared. It's 9x plus 7 times 9x minus 7. Okay, that's how it factors. All right, so look out for that. Let's do one more, and then we'll do an application of using this factoring to do something. What about 25x squared minus 4y squared? Now we really got to think of it. Well, this is really 5x everybody squared minus 2y everybody squared, right? Yeah, so now 5x plus 2y times 5x minus 2y. Okay, how did I know how to do that? I have to remember a squared minus b squared automatically can factor into a plus b times a minus b. You just have to know how to do that. Okay. All right, I think that's all the trouble you might get into with something like that. Now, in this next one here, it's not a difference of two squares, or is it? Oops, I've got that. 12x cubed minus 3x. Well, I'm looking for common factors. Here, I can see some. The 12 and the 3 have a common factor of 3, and then the x cubed and the x have a common factor of x. I can factor out a 3x. Undistributed 3x. Well, what would be left here? 4x squared minus 1 would be left, wouldn't it? Because if I remultiply it, I get 12x cubed minus 3x. I think I'm done, right? Because I factored out that greatest common factor, but I'm not done. Why am I not done? Because this is really a 2x everybody squared minus a 1 everybody squared, right? Yeah, so that falls into the difference of two square pattern. So that's really 2x plus 1 times 2x minus 1. Okay, this is a topic that if you haven't seen it ever, or if it's been decades, it's not fresh on your mind. I get it. Okay, and it's a lot for you to absorb in a quick little 20-minute video or whatever this is going to be. This is a whole night worth of crunching and doing these problems over and over and over again, but we just don't have the whole night to do it. Okay, but like I said, the topic does show up on your exam, so that's why I'm covering it. All right, so one of the things we do with this factoring is we can use it to help us reduce rational expressions. What the heck is a rational expression? Well, I have a lot of fun in my algebra classes. Just when I write that down, we take a few minutes and we figure out what the heck a rational expression is. And by the end of that 2 minutes, we have learned that it's nothing but a good old fraction. Okay. Oh yeah. And you know from some of my other videos how I like to torment my class with little sayings like math is fun. And fractions rule. Let me stick a rule in here. Okay, well, rational expression is just a big old messy looking fraction. Okay, but it's a fraction. Okay, and when we have fractions, we always want to simplify them. We use the word reduce them, right? When we're just talking about good old regular fractions. 25/30ths, how do you reduce a 25/30th? What do you do? Well, some people have kind of this mental reduction, and okay, you just kind of divide through there by 5, yeah, and we say it's 5/6, right? You kind of mentally know how to do it. What you're really doing is you're factoring. 5 times 5 is 25, 5 times 6 is 30. Goodbye a pair of 5s. So why goodbye? Well, they divide away into the value of 1. Something divided by itself is a 1, 5/6. We're going to do that now with polynomials. Okay, same idea. We're going to take a polynomial like this one, 6x plus 12 as a numerator, and 7x minus 28 as a denominator. And this one looks, just thinking about this is kind of boring here. Yeah, nothing's gonna happen here. I'm gonna skip that one because literally nothing happens there. What a dumb example that is. I'm looking at one of my books here. You know why they're using that? And again, this is really deep into the weeds now. Whenever you have a rational expression with variables in your denominator, in the world of fractions, you can never have denominator denominator equal to 0, right? You can never have a denominator equal to 0. So step number 1 is you examine those denominators and say what value of x would make that denominator equal to 0. Okay, we're not going to worry about that right now. Okay, we're going to simplify some rational expressions by using this thing we call factoring and canceling. Okay, so for example, if we do kind of an easy one here, 5x plus 35 over 20x. Okay, what can I factor out of that numerator? Well, I can factor a 5 out. What would be left? X plus 7. What can I factor out of my denominator? Well, I'm looking for canceling opportunities, so I would factor that 20 into 5 times 4. So we'll call it 5 times 4x because it's 20x. And then goodbye, goodbye. So this simplifies into x plus 7 over 4x. Now that's all I can do. Okay, I'm not going to do anything else with that because I have no more common factors. I can't cancel the x's here. Okay, I want to cancel common things to my numerator and my denominator. 7's got no x to give. If 7 had an x, then I could cancel all my x's away, but I don't. Okay, I have to have everything in this factored form to cancel. Just like if I had 5 plus 5 over 5 plus 6, I cannot, I'm going to say not equal to 5 over 6. In other words, I can't cancel those 5's out and call it 5 6. I can't do that. But if I have 5 times 5 over 5 times 6, now I can do that. That does equal 5 6. So I have to have multiplications to do this canceling, and that's what I have when I factored. I have multiplication. I don't have many more. Can't cancel. All right, what about this one? What about x cubed plus x squared on the top and x plus 1 on the bottom? What's common here now? Let's see. Well, I can factor an x squared out of the top, and that would leave me with an x plus 1. Okay, I can factor a 1 out of the bottom just to put it in a factored form here, and that leaves me with an x plus 1. And now I got a match, top and bottom, gone. What am I left with? Well, x squared over 1, but we would just call that x squared. Okay. Factor and cancel, just like reducing a regular fraction. Factor and cancel. This next one's got a trinomial in there that we have not talked about, so I don't want to do that. Let me make up a numerator here. What if we had, ignore this chicken scratch for a second. Let me just see what we've got here. Okay, what if we had 3x plus 15 on the top? And we have x squared minus 25 for my denominator, okay? Factor, what can I do on the top? I can factor out a 3, leaving me with x plus 5. What can I do downstairs in this denominator? Well, it's a difference of 2 squares, right? I can factor that a squared minus b squared. Is it really an a squared minus b squared? Is it? Yeah, it's an x squared minus a 5 squared. It fits that template of a squared minus b squared, okay? So it factors into what? A plus b times a minus b, so it's going to be x plus 5 times x minus 5, and looky there, goodbye, goodbye, we have a match. So this simplifies into 3 over x minus 5, okay? All right, so that's a quickie little introduction to factoring polynomials and simplifying rational expressions, hitting hard this difference of 2 squares, because again, that does show up on a couple of the practice tests, okay? So I'll be able to do that. All right, thank you. See you in the next video.